Well, students, we have made it to the final video of the chapter. I am using, as per request, a delightful blue color. Let's talk about parallel and perpendicular lines. The essential question for today is a somewhat nondescript one. What do parallel and perpendicular lines have in common? So, first of all, let's talk about parallel lines because we know something about parallel lines. We have already examined this topic in chapter 4. However, we will get back to perpendicular lines. Anyway, let's relate both parallel lines and perpendicular lines to this example line. I just want to graph it real quick. It's in slope-intercept form. So I start with a point of 2 on the y-axis and my slope up 3 over 2, up 3 over 2. Okay, so here's my kind of original line. Now, if we're talking about parallel, remember, parallel lines are lines that never touch. So let me actually change away my color from the lovely blue to a lovely green. Let's draw a parallel line that doesn't touch. Remember, in order for these lines not to touch, they need to have exactly the same slope. So this is a parallel line. It will never touch the blue line. And remember, that is because it has the same slope. So parallel lines, they have the same slope. They never, ever touch. However, perpendicular lines are new. Perpendicular, in case you don't know what that vocabulary word means, perpendicular means that the lines intersect at right angles. And I'm not sure if you remember what right angles are. Hopefully you do, because you're 9th or 10th or 8th graders. But perpendicular lines are ones that form a right angle. These two lines are perpendicular because they form a right angle. Look at the room you are in right now. If you look at where the wall hits the floor, you can see a right angle. So walls and floors are perpendicular. Likewise, walls and ceilings are perpendicular unless you have a slanty roof, which is rare in Morocco. So perpendicular lines. Now, if I'm looking at perpendicular lines on a graph, let's see if I can figure out, let me take off this green line. We know how parallel lines work. Let's see if I can figure out what line would be perpendicular to this blue line. Remember, perpendicular lines do intersect. So maybe it intersects right at this point, and they have a right angle. So I'm just going to do something right now. I'm just going to graph some points. Does it look like these lines have a right angle? Does this look like 90 degrees to you? I think it does. And if you tilt your screen a little sideways like I am doing right now, yeah, it totally looks like a right angle. Let's see. Did you hear my voice crack? That was fun. Let's see what is going on with these slopes. In my original blue line, I have a slope of up 3 over 2. What's the slope of this red line? Looks like down 2, right 3. So that would be a slope of negative 2 over 3. How does the slope of negative 2 over 3 compare to the original slope of 3 over 2? Hopefully you notice that one is negative and one is positive, and hopefully you also notice that they are reciprocals of each other. This one is 2 over 3, this one is 3 over 2. So perpendicular lines, here is how their slopes relate. Their slopes are what we call negative reciprocals. Negative refers to the fact that one of the slopes is going to be positive, one of the slopes is going to be negative. Reciprocals refers to the fact that I am flipping the fraction. So perpendicular lines, negative reciprocals. Our example here, 3/2 and negative 2/3. They are negative reciprocals. They form perpendicular lines. Let's do some examples. Remember, we are in the chapter where we are writing equations. So for example 1, I have this equation and I want to write a new equation of a line that is parallel to this line but runs through the point negative 9, 2. So first of all, let's think about the pieces of information that we have here. First of all, we have this line. This is like an old line. This is a line that they've given us. It is this line. I'm just graphing it real quick in slope-intercept form. But they're saying, hey, look, you need to write the equation of a new line that is parallel to this line, but through the point over -9 up 2. So my new line is going through this point, but it needs to be parallel to this line. And you can kind of sketch in a line, like those lines look like they'll never touch. I'm trying to find the equation of this line. How might we do that? Let's think about what the slope-intercept form would look like. In order to do slope-intercept form, I need to have a slope and I need to have a y-intercept. Now I could look over here for the y-intercept, but this is just kind of an estimate. We need a way to find it with algebra. But what is the slope? Do I know the slope of this line? And you should be screaming to yourself, yes, I do. I know the slope because I know that parallel lines have the same slope. So the slope in this old line is going to be the same slope as the slope in my new line. So I know for sure that my new line is going to have the same slope, -1/3 x. I still need to solve for the b though. The b is not 7. The 7 just refers to the old line. Don't even worry about this anymore. I need a point in the new line to solve for the b, and that point is of course -9, 2. This is a point in the new line. And I just realized I totally didn't graph -9, 2. -9, 2 is all the way over here. Anyway, you get the point. This is what the line really should look like. Whoops, my bad. So the point is, we're plugging -9, 2 into the y equals mx plus b to solve for b, just like you've done a million times in the past. So 2 is my y, -1/3 is my slope, -9 plus b. I know that -1/3 times -9 is 3. And so it looks like when I subtract 3 from both sides, my b is going to be -1. So the equation of this new line is -1/3 x minus 1. And it looks like I sketched my line pretty badly. It should be a lot more like this if it's going to hit through -1. Anyway, the point is, let's talk about how we did that. To get the slope, I just took the slope from the old line because I'm trying to get a line parallel to it. Parallel lines have the same slope. The b I found by plugging in my point, -9, 2, and solving just like we're very used to doing with slope-intercept form. Let's do an example with perpendicular lines. So same line, same point. So let me just sketch this real quick. It's the same starting line and the same starting point, but now instead of finding the line that is parallel to this old line, I need to find the line that is perpendicular to this new line. So how am I going to find that? First of all, as with the last one, I need to figure out a slope and a y-intercept. Here we are clearly not going to be able to see what the y-intercept is. It is way off the graph. But as with the other one, I can start with the slope. Remember, how do perpendicular slopes relate? They are negative reciprocals. So if hold on, let me spell reciprocals because it's a complicated word. Okay, there we go. Reciprocals. If the slope of this line is -1/3, what is going to be the slope of my new line? Well, taking the reciprocal makes it 3/1, and making it negative, if I have a double negative, it's going to cancel to a positive. So my new slope is 3/1, or just 3. And remember that the way that I found that is by taking the negative reciprocal of this slope. And check out this line. Does it look like it has a slope of up 3/1? I mean, I know I sketched it badly, but it looks like we're going about up 3/1, up 3/1, up 3/1, something like that. Anyway, as with the last one, now that I know my slope, I can plug in my point. So 2 equals 3 times -9 plus b. This is going to be -27. So if I add 27 to both sides, it will cancel. Looks like b is going to equal 29. And my equation is y equals 3x plus 29. To recap how I found that, I found the slope by taking the negative reciprocal of the slope of the line given to me in the problem. Negative reciprocal because I'm dealing with a perpendicular line. Perpendicular lines have negative reciprocal slope. I found the b by plugging in the x and the y. That was really, really fun. Or maybe it wasn't. Anyway, let's summarize. Remember, parallel lines, they have the same slope. Perpendicular lines have negative reciprocal slopes. So if, for example, you have a line with a slope of -5/2, the perpendicular line will have a slope of 2/5. I flip the fraction and I make it the opposite sign. That's all for today. Thank you for watching. Enjoy the parallel and perpendicular dreams tonight.